Hey guys, so my last video I talked about how we can change non-exact or decimal numbers like these to whole numbers. This video I will be telling you how we can leave numbers to a certain number of significant figures, or SF as we know it. Sometimes when you're working, your question will probably tell you to leave your answer to a certain number, like leave your answer to 3 significant figures or whatever. So this is a way to do it, and I've designed a rule for this as well, like the previous, so it'll be very easy for you to do this. Since we're talking about the differences, I have written down a difference. This is the main and in fact I guess the only difference between these two. So whole numbers only concentrate on the decimal point, this is an important thing, whilst SF looks at all. So what this means is, going back to our previous video, this is what we did. So whole numbers, the rule was, if the number after the decimal point is this and this, this and this, so we're basically just concentrating on the number after the decimal point. This is the point of focus. This is our focal point right now. However, for significant figures, it's not necessary that we have to focus on the number after or before the decimal point. We can focus on any number depending on the question. Like 1 significant figure would mean this, 2 would mean this, and ahead. It doesn't matter. So that is the main difference. Here's the rule, as I said. So I will be explaining this part in a bit. But it's really simple and easy to follow. After doing this, if the number is greater than 5, we do this. Less than 5, we do this. And this rule is applicable to any and every number. So there is just one exception, which I will be telling you in a bit, but it is mostly applicable on any number, and it is going to be a bit more complex than the previous, so bear with me. We're going to start by solving this one. So this is our main number. I've put it to 1, 2, 3, and 4 SF. I'm going to be doing this so that you can get a range of answers and you get how to do things here. So, to begin with, the first thing says, count to the number of SF the question asks on the main. This is the main number. The main basically means the number you're working on. So this is the number we're working on. So we count to the number of SF. That means if the question tells you to leave the number to 1 SF, then you know this is what they're talking about because it's on the first position. 2 SF, 1, 2. So we're looking at this number. 3 SF, 1, 2, 3. So we will be concentrating on this. 4 SF, 1, 2, 3, 4. So this. So not necessarily the number right after or before the decimal point. It could be any number on the number you're working with, basically. So to begin with, it says count the number of SF the question asks on the main. So we did that for 1 SF, so we know we're working with the 2. We do this to know what you're working with. So we know we're working with the 2 here. Next step says we look at the number right after it. So the number right after the 2 is this 3. So we look at the number right after it. If it is greater than 5 or equal to 5, we do this. If it is less than 5, we do this. Pay attention to the sign, please. This is greater than or equal to, and this is just less than. So 5 is not included here, it's included here. So this was in the previous thing as well. It's really easy to follow. So looking at this, since we're working with 1 SF, so we're looking at the 2. If we look at 3, we know that 3 is lesser than 5. So we know that we will be working in this category. So it says, if the number right after the SF number, I call this the SF number. So 1 SF, the number we're working on, I call the SF number. So if the number right after the SF number is less than 5, which it is in this case, all numbers after the SF number simply change to 0. This is a really important thing. So, as I said, the SF is the 2. All numbers after it simply change to 0. So these are all the numbers after it. They will change to 0 like this. So that just means it's 20. That's the answer. That's it. There's no other working to it. Nothing complicated, actually. So for 2 SF, 1, 2. So we know that we are working with 3 using the first step. Second step, look at the number right after it. So the number right after it is a 6. You should know that the decimal place doesn't matter. Whether there is a decimal or there isn't a decimal, we're still using this rule. As I said, it's applicable everywhere. So the rule doesn't change. we're still using it here. So the number right after the 3 is this 6, which is, we know it is greater than 5. So it will come into this category. So it says add 1 to the SF number. So our SF number we made clear was the second one. So since it's 2SF, so 1, 2, this. So we are going to be adding 1 here. And then we change everything after it to 0. So we change everything after the SF number, so that's this part, to 0 after we add 1. See, that's the only difference between this section and this section. Here we just add 1 before changing everything to 0, but in both cases we do have to change everything after the SF number to 0. So that's one thing to keep in mind. So the number before the SF number, this 2 here, doesn't change. As I said, this only applies to after the SF number, so the numbers before it stay the same. So the 2 stays the same. We add 1 to the 3 because the one after it is greater than 5, so that becomes 4. And then we change everything after this SF number to 0, so this part. So this becomes 24.0000. That means 24. Looking at 3SF, 1, 2, 3. So this is the one we're looking at. We look at the number right after it, that is this 5. Again, here we know it's not greater than, but it is equal to 5. So we will still be using this category. It says add 1 to the SF number as we did before. So this time, the 6 is what is our SF number, since it's 3SF, 1, 2, 3. So we're going to add 1 to this 6. So it's going to be a 1 here. And that would mean, so that becomes, the number before, as I said, stays the same. So 23 points, since we add 1 to the 6, that becomes 23.7. And then all the numbers after the SF number change to 0. So we've got these 3 after it. So 1, 2, 3. That's clear. For SF, it's same thing, really easy. 1, 2, 3, 4. We first count it. And then we know that we're working with the 5. We look at the number right after it, which is this 4. We know that it is less than 5, so we are again working with this category this time. So nothing happens. All numbers after the SF simply change to 0. The ones before, I'm saying this again and again, stay the same. So 23.65. So these are numbers before the SF. All the numbers after the SF change to 0, so 0, 0. The 4 and the 1 change to 0, 0. So that's basically the very simple rule you're going to use, and this applies to everything. So, I mean, obviously you're not going to be reading off the charts for all the questions. If you do 1 or 2 examples, in fact, just this video, you're going to get the hang of it, and it's really easy. So, there could be one problem if there are 9s in the question like this. Unless you understood the previous video where I explained how you can deal with the 9s, point is, a 9 can never hold a 1, because that would become 10, and that would change the digit number. So if, for example, I want to transfer a 1 from here, let's say we're looking at this 9 is greater than 5, so we transfer 1 to this, that would make it 10, and that would mean the number would become 71099, or yeah, something like that. So that would mean that it would change from a 4-digit number. This 4-digit number would change to a 5-digit number. So that is wrong. We are not changing the type of number. We're changing the numbers in the number, if that makes sense. So that would be wrong. So in the case of 9, I'm going to be solving this for you now. For 1 SF, as I said before, we count the number. So we know 1 SF, we're dealing with the first one. We look at the number right after it, that is a 9, so we know that it is greater than 5. So we add 1 to the SF number. So this is the SF number, the 7. So we add 1 to it, that becomes 8. And then everything after it changes to 0. So 0, 0, 0, 0.0. That's our 1 SF. If we're looking at 2 SF this time, 1, 2, so we're working with the 9. In normal case, as we did here, the 7 should stay the same, but because this is a 9, that might change, because if we look at the number after it, as we're supposed to do, 2SF, so 1, 2, we're working with this 9. The number after it is greater than 5, so again we will be working with this. So we add 1 to the SF number. As I said, the SF number is 9. If we add 1 to this, it will become 10. That doesn't make sense, as I explained why. So you keep adding 1 to the numbers beside it until you get the right one. That just means that because we have to add 1 here, but that would be wrong, so instead the 9 passes on the 1 to the 7. So it's like a game of passing the parcel basically. If this 9 can't carry it, it passes it on. If it can't carry it, it passes it on. So it's that easy. So for 2SF, this is 1, 2. The number after this is 9, greater than 5. So we add 1 to this 9. It cannot carry the 1, so it passes it on to the 7. So the 7 becomes an 8 again. And since the 9 passes the 1 to the 7, it becomes a 0. I made that clear in my previous video. And then automatically, everything after this 9 changes to 0, as the rule says. Everything after the SF number, this is the SF number, everything after it changes to 0 automatically. So 0, 0.0. That is our answer. For 3SF, 1, 2, 3, it's a 9, and the number after it is greater than 5. Also a 9, it could be a 6, it could be a 7. It's as long as it's greater than 5, we still have to add 1 to this SF number. As I said before, it cannot take the 1 because it's a 9. That would become 10. So it passes on the 1 to this. Unfortunately, this is also a 9. It cannot take the 1 either. So it passes it on, finally, to the 7, which can luckily take the 1. So again, that 7 changes to 8. Both of these 9s change to 0 because they have passed on the 1. And this is the SF number. Everything after it automatically changes to 0. So that would be 0.0. So that's our answer. For SF, 1, 2, 3, 4. We're looking at this 9 this time. The number after it is finally less than 5. So we're going to be looking at this condition. So all the numbers after the SF simply change to 0 without any addition. So everything stays the same, 99.0. This is the SF, so everything after it, that is just this 4, changed to 0. So that is our answer, 7999.0. The 9 and everything before the SF never changes, apart from if the 9 returns a 0. That was quite easy, I guess. Finally, the exception that I was talking about earlier is a 0. If there is a 0, in normal cases, it is treated as the usual rule. So we're going to do this with the usual rule that I explained earlier. So for 1 SF, we know that we're looking at this 2. The number after it is less than 5. It is a 0. So we're not going to do anything. We're just going to change everything after this SF number to 0. So that becomes 2000.00. Everything changes to 0 after the 2. Since the 0, this is less than 5. 2 SF, so we're dealing 1, 2. We're dealing with the 0. The number after this is this 3, which is also less than 5. So that becomes, the 2 stays the same, the 0 stays the same, and everything after this significant figure changes to 0. So although the answers are the same, but it is according to the rules, and this is the right answer. This is how you do it. Number 3, 3SF, so 1, 2, 3. We're looking at this 3. We look at the number right after it. This is a 5. So this time our condition changes and we're using this condition. So it says add 1 to the SF number and change everything after it to 0. So we're going to add 1 to this SF number. So that becomes 2, 0. These stay the same as I said before. We add 1 to the 3, that becomes a 4. And everything after the SF number, so we know that 1, 2, 3, we're working with 3 SF, so this is the SF number. Everything after it changes to 0, so 0.00. That's our answer. However, a 0 at the beginning is different. That means if you have a 0 that has nothing towards its left, So it's at the beginning of the number. It's not in between any number. It's not after any number. If there's a zero, if the zero is at the beginning, then it is not considered an SF number. If it is between some numbers, like here 2035, or if it is after something like 2560.5, it's after these numbers, and it's also at the in between these. So in those cases it will be using the normal rule. However, here, because it is at the beginning, you have to keep this in mind. Whenever it is at the beginning, it is not considered an SF number. So in this case, what we're going to do, what is considered the first SF number? This zero is not considered an SF number. This is not. So in that case, the first SF number will be this. This will be the second, third, fourth. That's how the count will go. So if we're looking at one SF, in normal cases we should look at this. But then in this case, as I said, because the zero is not considered an SF number, so we ignore these. And as I said, this is 1, 2, 3, 4. So we start our count from here. So 1 SF, so this becomes 1. So we're looking at the 2, not this 0, because it's at the beginning. So the 2. The number after it is 6, which is greater than 5. So we know the rule we're applying. We're going to add 1 to this 2. So it becomes a 3. And then everything after the 2 changes to 0. If that is clear. That becomes 0. The zeros remain the same. We're just ignoring them because they're at the beginning, but that doesn't mean they're not there at all. So we're going to put them in our answer, 0.003, because we've added 1. And then everything after it changes to 0. So 0, 0, 0. That's our answer. For 2SF, so 1, 2. So we're working with this 6. If we look after it, we have a 4, which is less than 5. So we know what to do. We don't do anything. We don't add anything. We just change everything after the SF number simply to 0. Our SF number is 6. What is before it stays the same. So 0.002. 6, and then these two change to 0. That's our answer. For 3SF, we have 1, 2, 3, the 4. We're working with the 4. The number right after it is a 0, which again is less than 5. So we don't do any addition. We just change everything after this SF number, the 4, simply to 0, which is already a 0, but then according to the rule, it's still supposed to be 0. So it's the same thing. So that would be 0.00264. That is, the answer stays the same. But this time we know why. Because everything after the 4 is supposed to change to 0. Because the 0 is less than 5. Hopefully that's easy enough to understand. And yeah, so that is the only exception in this rule. And the basic logic for this is that there should be no number from 1 to 9 after the SF number. If you look in both cases, in both rules, after the SF number, we have to change everything to a 0. So that just means that significant figures means that we don't want any number between 1 to 9 after our SF number, whether we use this condition or this condition. So that is the basic logic of the question. We have to make any additions as required. So again, it's very easy. We just apply this rule. This rule works everywhere. You have to understand the thing about the 9s though. I explained it in the previous one as well. It's called the 9 rule. I explained the previous one. You can watch it over if you want. So yeah, that is a simple rule. Just keep in mind that if there's a 0 at the beginning here, then it could be a 0.02, 0.2, 0.6. If there's a 0 at the beginning, you ignore it, even though you put it in your answer. But when you're finding the SF, when you're counting, your count will not start from that 0 because it is at the beginning. So keep it in mind, and thank you for listening.